Why did the king go to the dentist? To have his teeth crowned. 2019 paper 1, climate change and global warming did come up in 2018. However, not every aspect has come up, so possible questions to be covered in this video. Okay then, human causes of climate change and the enhanced greenhouse effect. It did come up partially last year, but didn't ask for the full explanation. What you guys need to be aware of is the concept that carbon dioxide is one of the greenhouse gases. The two that you need are carbon dioxide and methane. Greenhouse gases have the ability to trap heat within the atmosphere of planet Earth, and therefore it warms planet Earth up. So if you look at the two diagrams, on the left hand side you have the natural greenhouse effect, where the concept being that solar radiation passes through the atmosphere, reflects off the Earth's surface, and then the natural effect of that is that some of that heat will be trapped, but you'll see you've got 3 arrows escaping the atmosphere and leaving planet Earth. So greenhouse gases would naturally warm the planet. That is the natural greenhouse effect. What you guys need to be aware of, and this is the diagram on the right hand side as well as the explanation there on the left hand side, is that human beings have increased the amount of carbon dioxide in the atmosphere through the burning of fossil fuels and also through deforestation as well. What that therefore means is that the blanket surrounding planet Earth has become more effective. That therefore traps more heat, and that is called the enhanced greenhouse effect. So our diagram on the right hand side is the enhanced greenhouse effect as less heat escapes into space. You guys need to be able to explain that concept of increasing carbon dioxide emissions, trapping more heat, enhances the greenhouse effect. The only bit that's missing from that explanation is what is the cause of increasing carbon dioxide emissions, and that could well be the burning of fossil fuels for transport, the burning of fossil fuels for electricity, or the chopping down of trees, reducing the amount of photosynthesis, so therefore less carbon dioxide is in the world's forests. Okay then, natural causes of climate change. One of the trickier parts of the course, it did come up in the specimen assessment materials, so we do need to make sure that you guys can explain each of these. Do volcanic eruptions first. Volcanic eruptions obviously are totally natural, and they have the short-term effect of actually cooling the planet. They do that by releasing sulfur dioxide, which combines with dust in the atmosphere to form aerosols. Those reflect sunlight, therefore planet Earth's temperature decreases. However, long-term volcanic eruptions release carbon dioxide, which, as explained on the previous slide, will enhance the natural greenhouse effect, trapping more heat. Right, orbital change, probably the most complicated of the set. The orbit of planet Earth around the Sun is not a constant. For a 100,000-year cycle, it will move from more elliptical orbit that you see below to a much less elliptical orbit also seen below. The more elliptical the orbit is, you have a greater range of seasons throughout the year, on the grounds that if planet Earth is closer to the Sun, it means that the Sun's rays are going to be more concentrated, and more of planet Earth is going to be struck by sunlight, and therefore it's very warm for parts of the year. However, when planet Earth then swings to be further away from the Sun, that means less of the sunlight is going to be concentrated. The planet Earth itself will be hit by less sunlight because it's further away. There's a greater angle where the sunlight wouldn't hit the planet, and therefore you'll have ice forming throughout that time of the year. And then as the planet Earth then revolves back around the Sun to a closer orbit, all that ice would melt again. In a less elliptical orbit, you get far less range between your seasons, far less, and as a result, actually you'll end up with an ice age because it will never be warm enough to melt the ice on planet Earth. Solar output, the last one, it was previously thought that the energy released from the sun is a constant. It was called the solar constant. However, that isn't true. It looks like scientists have gone for an 11-year cycle of solar activity from greatest to lowest amount. Should you ever see sunspots, that means a greater amount of energy is being created and released by the sun, and therefore you'll end up with higher temperatures on planet Earth because the sun is radiating more heat. In my opinion, if you got asked for a natural cause of climate change, if you get the option, I would definitely go through volcanic eruptions, as it's probably the easiest to explain, and also you get that short-term, long-term to talk about as well. Right, climate change, mitigation slash adaptation. Bit of an introduction to this slide, and then we'll look at what success questions mean. So, management, as all management, aims to protect value and reduce vulnerability. In terms of climate change, there is mitigation and adaptation. Mitigation is to reduce the cause. It's the scientific fix, if you like. Can you cut down the amount of carbon emissions, as an example? Adaptation is to respond to the change, which means it's too late to actually stop the cause now. We've actually released too much carbon emissions, so what we now have to do is try to stop the effects as opposed to reduce the causes. If this is a success question, remember you're going to have to weigh up and make a judgment. Use the extentometer. It's totally successful, it's totally unsuccessful, or anything in between. And if possible, you might be able to categorize the mitigation or adaptations as socially successful or economically successful or environmentally successful, or actually unsuccessful for all of those as well. So we've got our 3 different management strategies there on the board. I'm going to take bus lanes first as a little local example of mitigating the effects of climate change, which is essentially have a separate lane for buses to move through. And what that means is buses won't be stuck in traffic. They'll have a smoother journey, less stop-starting. That therefore reduces the amount of carbon emissions, as you're not constantly having to rev the engine of the bus. As a result of that, if the bus moves faster, the concept is that the bus stops and starts less, so therefore reduces less carbon dioxide. Where have you seen bus lanes to before? Well, you've seen them in Plymouth. However, the example I'd like you to talk about is Truro, because we know what's happened to that bus lane on the approach from St Austell to Truro. A little bit more explanation first, though. The idea is if the bus shoots past traffic, as you can see in that image there in the bottom left-hand corner, the people commuting to work will look out of their... what car is that there? Is that, I'm going to say it's a BMW, but it might not be. And the bus shoots past them. They then look and go, oh, I tell you what, Ethel, we should get the bus from now on because it'll be a lot quicker. If that happens, it therefore means you have less cars on the road as well, so therefore less carbon emissions on top of that. I've mentioned the Truro bus lane. I couldn't help myself get to it early. Remember what happened to the Truro bus lane, though? The amount of congestion caused as people refused to use the bus and still wanted to drive had a hugely negative impact on the amount of congestion in the city, and the bus lane was scrapped after about 2 weeks. So if you need a success question, you can always use Truro bus lane regarding climate change. Our 2 global strategies are also on the right hand side. I'll start with the top image, which is the Great Green Wall. 7,000 kilometre long, 15 kilometre wide wall of trees to cover the Sahel region of Africa. Example tree there is the acacia tree, which I'm reliably informed is on Minecraft. If that helps anyone remember the tree, then great. How does it work? Well, what it tries to do is it tries to trap CO2 or get the trees to absorb CO2, if you like, so there's less CO2 in the atmosphere. And the way that's going to happen is through the natural photosynthesis of these trees, it will trap carbon dioxide, absorb carbon dioxide, so there'll be less in the atmosphere. Has it worked? Well, partially. If you took Senegal as the example, it seemed to have shown quite significant steps there where the wall has been completed in Senegal, and the local people also have benefited through this strategy through mangoes now being able to be grown in the area. So there is some evidence of success. However, the wall as a whole is incomplete. The reason for that is these countries that straddle the Sahel, for example, Chad, South Sudan, etc., simply don't have the money to actually plant these trees and manage its planting and its upkeep. And as a result, the Great Green Wall is incomplete, has pretty large holes within it, hundreds of kilometres long, where the wall has not been completed. And the Sahara Desert continues to grow 400 metres south every year. So with that in mind, quite simply, the strategy that hasn't worked fully, although locally in Senegal, it has worked. Okay, and the final one is the Paris Summit, a summit of nearly every country on planet Earth, where delegates from the governments adopted their plan, if you like, adopted their aim to reduce carbon emissions. The concept being to try to keep global warming down to a maximum of a 2-degree warming by 2100. Now, the idea here is if all these countries go in together and say, this is our aim, this is what we're going to do, then you get this global response. There's no point in just one country doing this, because the rest of the globe will contribute so much carbon dioxide that actually that one country, its efforts are essentially irrelevant. However, if every country does it, then actually potentially you could see a reduction in the effects, for example, of a rising sea level. Has it worked? Well, there was a lot of signing up. I believe 196 countries signed up to the Paris Summit. So that is your evidence that globally it's happening, it's working. But then there comes lots of criticisms there afterwards. 2 countries have left already. The United States of America and Australia have pulled out of their commitments to reduce carbon emissions, and in addition, the commitments made are not legally binding. If they don't do if I don't know, Burkina Faso says, oh yeah, we'll cut down our emissions, and they don't, well actually there's no penalty for them because they don't have to do it. Legal, like if you break the law, obviously you're going to be tried in court and go to jail. If you break this commitment, then actually nothing happens. So if it's a success question, you could certainly argue that the effect or the success of this will be seen in the future, but probably isn't going to have the impact that it was. The other one here is that you could be asked a question on management, which is related to importance as opposed to success. So is it important to try and manage climate change? So remember, in terms of importance, weigh up and make a judgment. They can be very important or not important, socially important, economically unimportant, whatever you wanted to go for. Good news here is you use the exact same case studies of the Great Green Wall and the Paris Summit, and all you need to do is to identify if the management is important or not. So, is it important to manage a 3mm sea level rise? Is it important to manage a 0.85 degree rise in temperature? Is it important to manage the fact that we have 5 times more extreme heat days every year in the UK? At the end of the day, you can argue however you so want to, and the concept being that it doesn't matter what your answer is, but you just have to back up these points using these sort of figures to show why it is important, or alternatively, why it's not.